All right, guys, this is our first video in the geometry unit. This first video is basically about the geometry basics. It's just giving you a refresher course of things that you've learned in 5th grade and things that you will need throughout this unit. So make sure you have your guided notes page and a pencil, and let's go ahead and get started. The first vocabulary words are really the basics: a point, a line, a ray, and a segment. Go ahead and write down those definitions, and then we'll come back and we'll do a little bit of work with them. So pause the video and come back. All right, so let's do a couple things with the line, the ray, and the segment. So important thing you need to know is when you identify a line, array, or segment, you must use the symbol. You must use a symbol. So this is my line, and to identify a line, all I need to do is to make sure and use 2 points on that line. I can use any of these letters that are on the line. So I'm going to choose point B and C, and to make sure I identify it as a line, I need to use the line symbol on top of it. I could have also identified it as line AC, line CD. Any of those would have worked. Okay, so I just have to choose 2 letters on the line. For array, you're also using 2 letters, but array has an endpoint and then goes forever in one direction. So this is array. It goes forever in this direction. So I could say CE is array. The endpoint, it does matter. The endpoint has to be on where the endpoint is on your figure. Also, a line, there are rays within the line. If I wanted to say ray BD, BD would start here and go forever in this direction. It would not include the point A because this is where it starts and it goes forever in this direction. If I asked for ray, let's say BD, oops, let's go BC, sorry, BC, that means it starts on B and goes forever in this direction. It does include the point D. Okay. All right, and a segment is just a part of a line. It is just a part. So if you look, a segment I could say is AC, and here's the symbol on top. That means it goes from here to here. So it would not include the point D, but it would include point B. All right, so that's just a refresher on that one. All right, let's move on to part 2, which is angles. An angle is formed by 2 rays with the same endpoint. This is my endpoint here. The endpoint is called your vertex. This is where the 2 rays meet. This is my symbol for an angle. If you are identifying an angle, you must use 3 letters. 3 letters, and the vertex must be in the middle. So if you look at this one, let's say this is the angle we're looking at. I can identify this as angle. I have to start with my symbol, angle YUZ, or I could call it angle ZUY. You notice how the vertex is always in the middle. Okay, it's always in the middle. If I'm only looking at one angle, like this one over here, see, this one has 2 different angles. But if I'm only looking at one angle, I can also identify it using the vertex. So I could call this angle B. I can't use the vertex in this one because there's 2 angles. So if I said angle U, you wouldn't know if I were looking at this angle or if I were looking at this angle. Okay. All right, so here are my angles. I want you to take some time and see if you can identify using the definition what angle this is. I think you'll be pretty good with this first part. The other part you might need help with. So go ahead and do those and come back and check for your answers. All right, so here are your answers. I'm guessing the beginning ones you were pretty sure about these: acute, right, and obtuse, and straight. You've done those a lot. I'm not sure if you were familiar with the words vertical angles, complementary, and supplementary angles. So let me just talk a little bit about those really quick. Vertical angles are angles, opposite angles that are formed by intersecting angles. So if intersecting lines, sorry. If I have 2 lines, do you notice how it forms 1, 2, 3, 4 angles? So what this means is that vertical angles, so they're opposite each other. So angle 2 and angle 4 are right opposite of each other. And the significance of that is that because they are vertical angles and they're opposite of each other, that means they have the same measurement. So if this one measures 120 degrees, then this one is also 120 degrees. Which on this one, so 1 and 3 are also vertical angles. So if this one is 60 degrees, then that means this angle has to be 60 degrees. Complementary and supplementary. Complementary, I'm looking at a 90-degree angle, but now that has been split into two different angles. So that means the measurement of both of those angles has to add up to 90 degrees. So let's say here's my right angle here. So if I split that in two separate angles, even though this one's very, very small, maybe just 10 degrees, this one would have to be 80 degrees. They have to add up to 90. So supplementary is 180-degree angles. We're looking at this, and it's been broken into two different angles. So these two angles have to add up to 180 degrees. All right, let's move on to part 3, which is polygons. Let's look at polygons. Let's see if we can come up with a definition of polygons, looking at pictures that are polygons and ones that are not polygons. So what are you noticing? All right, hopefully you noticed that all polygons are closed figures. So that means they have to have at least 3 sides. Hopefully you're noticing that a polygon has all straight lines. And a polygon, they cannot have intersecting lines. Okay, so those are the characteristics of a polygon. Now let's be a little bit more specific with polygons. Let's look at polygons that have more than 3 sides. Well, actually 3 or more. First of all, look at these 3 up here. I want you to decide which ones are polygons and which ones are not. Take a second and write yes or no on those to tell me which ones are and which ones are not polygons. All right, hopefully you said this one yes is a polygon. No, this one is not because it has curved lines. No, it is not because this has a curved line. And yes, this one is a polygon. Okay? Go ahead and take some time here and write down, see if you know the names of each of these shapes. Obviously, you can figure out the number of sides by just counting, but see if you can tell me the names of them. Push pause and then come back for the answers. All right, I'm pretty confident that you know the majority of these, the ones you might have had problems, especially with this one, a heptagon. A 7-sided figure is called a heptagon, and maybe a hexagon, not sure. You really need to be aware of these, especially we're going to focus on triangles and quadrilaterals. Oops, I made a mistake here. Hopefully you caught that one. This is a quadrilateral. I was a little bit more specific. This is a quadrilateral right here. So I was being more specific. It was this one is a parallelogram. So we're going to talk about that. So let's go to the next slide and we'll be a little bit more specific. All right, we're going to start with triangles. We're going to classify them by both their angles and their sides. So again, I want you to take some time and see if you remember the name of these specific triangles. Take some time, hit pause, and come back when you are ready. All right, I feel pretty confident about these 3. I bet you were confident about those. These, not so sure. Remember, a scalene triangle, if we're looking at their sides, they have all different lengths. An isosceles has 2 lengths the same. This is how they're showing it. They're doing little notches there. That lets you know that this side is equal to this side. And an equilateral, that's pretty easy because it's equal. It has all equal sides. So if you notice, it's showing 3 little notches. That means that all 3 sides are the same. Another way they can show that maybe with the scalene is if they put 1 notch here, 2 here, and 3 here. That's showing that each one of those are different. So you might see either one of those. I remember isosceles as you have 2 eyes, so 2 sides are the same. That helps me to remember. Another important part is to know that the angles in a triangle should all add up to 180 degrees. They should always add up to 180 degrees. All right, let's do a little bit of practice here. All right, I want you to take some time. Don't worry about the numbers that they're starting at different numbers. I want you to see if you can classify these triangles by their angles, and then classify these by their sides, and then see if you can figure out the remaining angle here, what angle A, the measurement of angle A. So push pause, take some time, and come back for the answers. All right, let's see how you did. Let's see. Here's one obtuse angle, so that makes that an obtuse triangle. Here is a 90-degree angle, so that makes it a right triangle. And all of these are acute angles, so that's an acute triangle. All right, looking at their sides, here are two lengths that are the same, so that is an isosceles. These are all equal, so that's an equilateral. And all of these are different, so that is a scalene. My angles here, everything inside the triangle, the measurements need to add up to 180. So right now, 115 and 35, that's 150 degrees so far. So there would be 30 degrees left. All right, hopefully that was quick practice for you. And let's move on to quadrilaterals. All right, part 5, quadrilaterals. All right, at this point, I want you to see if you can write down the definition of these specific quadrilaterals. Let's see if you remember them. So take some time, hit pause, and come back and see if your definition is correct. If you're unsure, then just go ahead and write down the definitions. All right, let's go through these definitions to make sure you understand them. A trapezoid. A trapezoid is a different quadrilateral. It's normally kind of off by itself because it is different. It is a quadrilateral that has only one pair of parallel lines. This is a parallel line. It's parallel with this one. So these two are parallel lines. This one and this one is not. A parallelogram has two pairs of parallel lines. This line is parallel with this one, and this line is parallel with that one. A rectangle is a quadrilateral. It's also a parallelogram. I should have written a parallelogram. It's a parallelogram with 4 right angles. Again, these two lines are parallel and these two are parallel, and it also has right angles, 4 right angles. A rhombus is a quadrilateral with 4 equal sides. So the sides, the lengths of the sides are equal. Okay, all the sides are equal. Don't get confused. I was probably confusing you with the parallel lines there. And the square, it's a quadrilateral with 4 right angles and 4 equal sides. So the sides are all equal, and it has 4 right angles. Okay, and the angles within the quadrilateral should all add up to 360 degrees. That becomes important as well. All right, so those are my quadrilaterals. Last part, part 6. Not sure if you've been familiar with congruent or similar, congruent and similar. So why don't you go ahead and take some time and write down the definitions, and we'll come back and I'll talk a little bit about it before you leave. All right, so congruent means two shapes are congruent if they are the same shape and size. They have the exact same lengths and angles. Basically, a congruent figure is just something, these are the exact same things. Maybe it's been turned, maybe it's upside down, maybe it's a mirror image, but it is the exact same shape. Okay, so congruent means the exact same. Similar. Two polygons are the similar shape, but they're different sizes. The thing about a similar figure is that their angles are the exact same, but their lengths are not. They're proportional. So what that means is obviously these are similar shapes. This is a pentagon, but this one is smaller. But if you look, if I were to take this pentagon, look how that angle is exactly the same. This angle is exactly the same. This one is exactly the same, exactly the same, exactly the same. But what is different is the lengths are not. So this one is proportionally bigger. So if I were to drag this out a little bit, I could get one that was, let me see this. I could get it the exact same. So now they're congruent, But once I make it smaller like this, they are proportionally, this one is proportionally bigger. So let's just say, for example, I said that this was 2 and this one was 4. So this one would be 2 times as large. Okay? So congruent means the exact same. Similar means they have the same shape, but their lengths are not the same. All right, so hopefully you had a quick refresher on all those geometry units, and then you have something in your packet to start working on for tomorrow. All right, have a good day.